Okay, so what we're going to be doing today is solving fractional equations, also known as rational equations. You could see the steps here, but I'm going to apply these steps as we do an example. Okay, so if you can turn to number 29 in your packet, we're going to start off with this one. Okay, so if you read the first step says we want to find a common denominator. So let's look at our denominators. We have a 6, a 10, and a 15. So if we listed out a whole bunch of multiples of 6 and a whole bunch of different multiples of 10, and let's do the same for 15. What you'll notice is that the smallest number that they have in common is 30. So this is going to be our common denominator. So what we're going to do is we're going to rewrite each of these fractions with a denominator of 30. Okay, now what we have to do is we have to let's look at the first fraction. We want to say, well, what do I multiply this denominator by to get it to become a 30? Well, 6 times 5 gives us 30. So let's multiply the bottom by 5, but in order to keep the fraction equivalent, let's also multiply the top by 5. All right, if we look at the second fraction, what do we need to multiply this denominator by to make it a 30? Well, this time we're going to multiply it by 3. So if we multiply the denominator by 3, we're also going to multiply the numerator by 3. And in our last fraction, we need to multiply this 15 by a 2 in order for it to become a 30. So I'm going to multiply top and bottom of this one by 2. Okay, so let's just multiply everything out. So I'm going to distribute this 5 to the x and the negative 4. So 5 times x is 5x, and 5 times negative 4 is negative 20. And we've already said that 5 times 6 gives us 30 in the denominator here. Okay, so then 3 times x is 3x, and 3 times negative 2 is negative 6. And again, 3 times 10 gives us this denominator of 30. And finally, 2 times 31 is 62. And again, 2 times 15 gives us our common denominator of 30. Okay, now once we have step 1 done, once we find a common denominator, let's go on to step 2, which says cross off the denominators. So that's our quick step. You could just take them and just cross them right off. On to step 3, solve remaining equation. So the equation that's formed from our numerator. So we're going to solve this equation right here. Let me just rewrite it. So 5x minus 20 plus 3x minus 6 equals 62. Okay, so let's solve. I'll combine my like terms. 5x plus 3x is 8x. Negative 20 minus 6 is negative 26. And I'm going to bring down the equals 62. Okay, so now I'm going to want to add 26 to both sides, leaving me with 8x equals 88, and then just divide by 8, leaving us with x equals 11. Okay, now number 30 in your packet we're going to skip because if you notice, it's not even an equation. There's no equal sign. So unfortunately, there's nothing to solve. All right, so let's take a look at number 31. All right, now with this one, there's a couple things we have to do first before we can find our common denominator. The first thing we want to do is we want to make everything into a fraction. So I'm going to take this 1 and put it over 1. And the other thing that's going to help us to find a common denominator is if something can be factored, I'm going to recommend that you factor it first. So if you look at this denominator, this right here is going to factor to be x plus 5 times x minus 5. Now, when you look at the other denominators, this x plus 5 times x minus 5 actually is going to be our common denominator because we can get all of the other denominators to look just like that. All right, so let's do that. Let's make our common denominator x plus 5 times x minus 5. And even though there's just a 1 over on this side of the equation, you are going to have to get this denominator to be the same. Okay, we want that to also say x plus 5 times x minus 5. Okay, so if we look at our first fraction, we have the x plus 5. It's missing the x minus 5 that the common denominator has. So let's multiply the top and the bottom by x minus 5. Okay, our second fraction already has the x plus 5 times x minus 5 that the common denominator has, so we can just leave this numerator alone. And then in this last fraction, it's missing the x plus 5 and the x minus 5, so let's include the x plus 5 and the x minus 5 in the denominator, and that means we also have to put it up here in the numerator as well. Okay, so let's just write what we're left with after we have decided what to multiply each fraction by. So what we're going to do up here is we're going to double distribute out these two binomials. So x times x is x squared, x times 2 is 2x, negative 5 times x is negative 5x, and negative 5 times 2 is negative 10. Okay, now this x minus 1 I'm just going to bring right down. And then over here, I mean, you may look at this and say, oh, look, that's a difference of two squares. So that's going to multiply out to x squared minus 25. But if you're not sure, just double distribute it out. So you get x squared minus 5x plus 5x minus 25. Okay, step 1 is done. We now have a common denominator for everything. So we can move on to step 2, which is to cross off your denominators. The quick step. And then step number 3 is just to solve the remaining numerators up here. Okay, so I'm first just going to rewrite it. So we have x squared minus 2x, I'm sorry, that's a plus 2x, minus 5x minus 10, and then I'm going to bring down this plus x minus 1, and bring down the equals x squared minus 5x plus 5x minus 25. Okay, so let me see what like terms I can combine. So on the left-hand side of the equation, this x squared doesn't combine with anything, so I'm just going to bring it down. Then we have a positive 2x, a negative 5x, and a positive x. So 2x minus 5x is negative 3x, plus x is negative 2x. And then when I combine my negative 10 and my negative 1, that gives me negative 11. Okay, on the other side of the equation, what's going to happen is the negative 5x and the positive 5x are going to cancel off, leaving me with just x squared minus 25. All right, now these x squareds, if you have one on the left-hand side of the equation and one on the right-hand side of the equation, I mean, you could subtract x squared from this side and x squared from this side, but what's going to happen is when you do that, they're going to cancel. So now I'm left with negative 2x plus 11 equals negative 25. So let's just add 11 to both sides. So that leaves us with negative 2x equals negative 14. And when you divide both sides by negative 2, it leaves us with x equals positive 7. Now, something that's really important to check for, when you have x's in the denominator of your original question, you want to go through and you want to make sure that your answer doesn't create an undefined fraction. So what that means is you want to go through and make sure that your answer isn't creating a 0 in any of the denominators. So if we take a 7 and substitute it into this denominator, 7 plus 5 is not equal to 0. And then over here, if I take 7 and plug it in, 7 squared minus 25 also is not equal to 0. So this answer is okay to have. Okay, the next one. If you take a look at these denominators, right, first thing you'll notice is over here on the right-hand side of the equation, that's going to factor to be x plus 3 times x minus 3, right? That's a difference of two perfect squares. Now here we have an x plus 3. And if this said x minus 3, it would match up with this denominator. But keep in mind, if you remember from yesterday's lesson, you are allowed to switch the order of this to say x minus 3 as long as you switch the sign in front of that fraction. So this subtraction sign is going to become an addition sign. Okay, so as you can see, our common denominator is going to be x plus 3 times x minus 3. So let's just bring all this down. Okay, so our first fraction has the x plus 3 in the denominator. It's missing this x minus 3. So let's multiply top and bottom by x minus 3. The second fraction is missing the x plus 3. So let's multiply the numerator and the denominator by x plus 3. And this last fraction already has both, so we can leave it as is. Okay, so then if I take this 1 and distribute it to the x minus 3, it stays as x minus 3. If I take the 2 and distribute it to the x plus 3, it becomes 2x plus 6. And then I can just take this 4 and just bring that right down. So now that we have common denominators, we can cross them off. And let's just solve what we're left with. So we have x minus 3 plus 2x plus 6 equals 4. All right, so if we combine our like terms, x plus 2x is 3x, and negative 3 plus 6 is positive 3. And when I bring down the equals 4, I can then subtract 3, leaving me with 3x equals 1, and then divide by 3. So that's going to leave me with x equals 1/3. And again, I want to go through and say, does this value, when I substitute it into the denominators, create an undefined fraction, a 0 anywhere in the denominator? And no, it doesn't. So this answer looks good. Okay, and the last one we're going to do together is number 33. Now, if you look at the fraction again on the right-hand side of the equation, that can be factored. You could pull out a GCF of x, and it would leave you with an x minus 7. So as you can see, our common denominator is going to be x times x minus 7. Okay, so the first fraction is missing an x in the denominator, so let's multiply top and bottom by x. The second fraction is missing the x minus 7, so we'll multiply top and bottom of that by x minus 7. And this last fraction has the x and the x minus 7, so we'll leave that numerator and denominator alone. Okay, so here we have, if we distribute the x to both terms, in this numerator we have x squared minus 3x. Okay, now if I distribute the 1 to the x and the minus 7, we're going to have x minus 7. And again, the fraction on the right-hand side of the equation, we're just leaving that numerator alone. Okay, now this time when we cross off the denominators, because of this subtraction sign here, we have to remember to distribute the subtraction sign to both terms. Don't just distribute it to the x, you have to distribute it to the negative 7 as well. So that's going to leave me with x squared minus 3x. Now when you distribute it, you're going to have a negative x, and then a negative 7. Well, a negative times a negative is positive, so it's going to be positive 7. And then you can bring down your equals 28. Okay, so this time, since we have an x squared, we want to get everything to the same side of the equation as the x squared. So I'm going to subtract this 28, and let me combine like terms in the same step. So this x squared is just going to come right down. I can combine the negative 3x and the negative x to give me negative 4x. And then 7 minus 28 would be negative 21. Now from here, I'm just going to factor this. So I'm going to put an x in the first spot in each parenthesis, and two numbers that multiply to negative 21 and that add to negative 4 would be negative 7 and positive 3. So now when I make my t-chart to solve, I wind up getting x equals 7 and x equals negative 3. Now if you notice, in this example, this 7 right here, if you were to take this 7 and plug it back in for x into this denominator, 7 minus 7 is 0, which means we would have an undefined fraction here. Even if you plugged it in over here, 7 squared minus 7 times 7 is also 0. So what we have to do is we have to cross this off. This solution creates what we call an extraneous root. Okay, let's see if I could fit that. I'm going to do it in another color so it kind of stands out. This is called an extraneous root. Although we got that solution when solving, it isn't actually a solution to the equation because it would create an undefined fraction. So the only solution in this case is the x equals negative 3. Okay, now what I'd like you to do is I'd like you at this point to try out the next two questions on your own, number 34 and 35. You're going to have to stop the video. And then when you're done doing them, you can restart the video, and I have the answers up here, and you can see how you did. Okay, so here's the answer to number 34, and if you notice, we again have an extraneous root. This x equals 4 would create an undefined fraction. 4 minus 4 is 0, and you cannot have 0 in the denominator of a fraction. And then here is our work for number 35. Okay, you could either write it as a fraction, x equals -4 fifths, or as a decimal, x equals -0.8.